Welcome to Electromagnetism Part 3. In this video, we will determine the magnitude and direction of the force on a current carrying length of wire in an existing magnetic field. So the force is the force due to the magnetic field. So we'll start and label that FB. Current is I. Length is lowercase l, in an existing magnetic field whose strength, of course, is given by the symbol capital B. Once again, we're going to start by doing the magnitude first, the easy part. It may be obvious just from the title that the force is going to be dependent on how much current is passing through the wire, the amount of wire in the existing field, the length of the wire exposed, and the strength of the magnetic field itself. And indeed, the magnitude FB equals BIL. And we throw on there a trig function sine theta. The theta, it takes into account if the wire is not perpendicular to the magnetic field. It takes into account that there will still be a force on that wire, it just won't be the maximum force. So to maximize the force on a current carrying length of wire in a pre-existing magnetic field, the wire has to be perpendicular to the magnetic field itself. And perpendicular would be 90 degrees, sine of 90 is 1. And so you're maximizing your force by doing that. If the wire is not perpendicular to the magnetic field, there still will be a force on it, just won't be the maximum force. And you can also see that if you put your wire parallel to the magnetic field, in other words 0 degrees or 180 degrees to the magnetic field, that the sine of 0 is 0 and you won't have any force at all. So it takes into account, sometimes we drop it off if we know that we drop that part off the equation if we know that the wire is perpendicular because sine 90 is 1. All right, let's go next to how do we determine the direction. In our diagram here, you can see that we have our wire positioned in between opposite poles of a magnet. The dashed red lines show the portion of the wire in between, exposed to the magnetic field itself. So this would be the L value mentioned in the equation. And our wire has the bottom side of it connected to a positive and the top side of it connected to a negative. So the conventional current here would run up through the wire itself. The direction of a magnetic field that it's exposed to is away from the north towards the south, outside the magnet. So our B value is to the right. For the direction of the force on a current carrying wire in an existing magnetic field, we use another hand rule, the right hand rule, in which you're going to take and make a gun, so to speak, as if you're a member of the FBI. And you're going to take and point your middle finger to the left. The barrel of the gun is your index finger, and your thumb sticks straight up in the air. Okay? So this is what we use to determine the direction of this force. And here's what your 3 digits represent. Everybody knows the FBI. Well, here's your gun. F is your middle finger. B is the barrel of your gun. And I is the direction of your current. And that's your thumb. You have to know which variable goes with which of your digits. Okay? So FBI is if you're making your gun and it's bottom up. So FBI. All right. Now, what's neat about this, you notice that your three digits, your middle finger, your index finger, and your thumb, orientated like that, are all 90 degrees to each other. So in this example, for example, the F value is in the X plane, the I value is in the Y plane, and the B value is in the Z plane. What this helps you out is you can always determine which plane your answer has to be in even before you begin solving the problem. In our sample here with the wire and the magnetic field, the B value is in the X plane and the I value is in the Y plane. So we know before we even hand rule this question that the F value has to be in the Z plane. So the only possible answers for this force are into the page or out of the page. And you can use that as a test taking strategy. All right, so let's go ahead and hand rule this then. Our thumb sticks straight up. Our index finger points to the right. And when we do that, our middle finger is pointed into the page. So FB is into the page, and the symbol for that is X, or a circle with an X around it. All right? And that's how you determine the direction of the magnetic field for a force on a current carrying length of wire in an existing magnetic field.